Hello and welcome to this week's video in our course Competition Policy and Strategy. In this video we are going to talk about the solutions to assignment number 5 on the topic market power. In the first exercise on this assignment we are asked to consider a Cournot oligopoly with n firms producing a homogeneous good. The total quantity of this good is denoted capital Q, and we know the demand function in this market, which reads Q, so quantity of price, equals 250 minus P. We are further told to assume that all firms have constant marginal costs of C equal 100 and that there is no fixed costs in production. Alright, now in the first task we're asked to find the market equilibrium in this previously outlined situation, and the only difference to what we already did in the previous weeks now is that we are asked to find the market equilibrium as a function of the number of firms in the market n. Alright, so in previous weeks we were always looking at situations where we knew the number of firms in the market, and then we're asked to find the equilibrium quantity and price that result under this specified number of firms. Now, this week we want to analyze the number of firms as a parameter. So, as a starting point, we will have to have a look at the market equilibrium as a function of the number of firms called n. Alright, and how do we come to the market equilibrium as a function of the number of firms? Well, we at first, of course, start with the usual profit maximization problem in the Cournot oligopoly. The only difference, of course, is that once we're at the point where we are substituting for the quantity that all other firms produce, so Q with an index of minus I, the quantity of all other firms, well, we can no longer plug in the number of all other firms. But instead, and this is what you see in this point down here, we will instead keep this parameter n in our equations. So the quantity of all other firms, Q with an index minus I, equals n minus 1 times the quantity of each individual firm in this market. And in this specific case, we are not even going to substitute the number of firms n. But instead, if we just stick with this parameter n and solve our equations for any number n, then we arrive at the results that are pointed out in these last two bullet points on the slides. And that is first the total quantity in the market, which results as capital Q equals n times 150, all divided by n plus 1. And then, using this total quantity in the market, of course, we can, by plugging this value into our demand function, we can find the equilibrium price in the market, which turns out to be 100 plus 150 divided by n plus 1. Alright, now knowing the quantity and the price in equilibrium in the market, of course all as functions of the number of firms n, we can then calculate the profits of all firms as a function of the number of firms in the market. And that's exactly what we're doing in this last and final bullet point on this slide, where we simply calculate the profits of all firms, or of each individual firm to be more precise, as we usually do by simply multiplying the profit margin, P minus C, with the individual produced quantity, and then of course subtracting the fixed costs if applicable in the case. Alright, and with that we result with this we derive the profit function as a function of the number of firms in the market. Down here it's written 150 divided by n plus 1 all squared minus the fixed cost capital F. Alright. So in the next step then, now knowing the profit of all firms in these general terms, generalized for the number of firms and generalized for the fixed costs in the market, we are next faced with this question. How many firms will be in the market if there is additionally fixed costs of capital F equal 100? All right, so now we are faced with one value for the fixed costs capital F, and are asked to derive, based on this information, what is the number of firms in the market in equilibrium. So really the number of firms is treated as an endogenous size in this version of this model. All right. Now, how can we find out what will be the number of firms in equilibrium in this market? Well, conceptually, we first need to realize that market entry occurs in these models until economic profits are reduced to zero. All right. So the calculus of the firm really is, as long as the firm can expect non-zero profits or even positive profits, a firm will enter the market and realize these non-zero profits. And this, of course, results in market entries as long as the profit of the number of firms that are in the market after the entry are still non-zero and positive. All right. In addition, we know that zero profits in these settings where we not only have marginal costs, but instead we also see fixed costs. In this kind of setting, we know that zero profit is reached if and only if the price equals the average costs of each individual firm. All right? Only then it is the case that the firms make exactly zero profits. And we have spent quite a bit of time in the previous weeks discussing why this must be true. So I would like to refer you to our previous videos on this topic more precisely. We were, for example, discussing this in the context of dynamic efficiency. All right, so from all this, we then know that the economic profit of all firms as a function of the number of firms n needs to be zero for this condition to hold. All right, we can make use of this statement and of this condition. And it's written on the third bullet point on this slide. All right, so in order to find the number of firms, we can consider the profit function as a function of the number of firms that we derived earlier in the previous task and set it exactly equal to zero, right? Because as we have discussed a minute ago, as soon as this condition is met, there is no additional market entries anymore. So by making this statement, by forcing the profits of the individual firm to be exactly equal to zero, we can calculate that the number of firms in the market will be 14 if this condition is met, right? We simply state this condition, then we solve this condition for n, and the solution provides that this statement is true if n takes a value of 14, or to interpret the results, we know that the profits of each individual firm are zero as soon as there's exactly 14 firms in the market. All right. Now, in the next task, we are asked to, based on this idea that we can find the profits as a function of the number of firms n, we are now asked to go even one step further and calculate the welfare as a function of the number of firms. The welfare function now called W as a function of parameter n. All right. Then in a subsequent step, we are asked to calculate welfare for a whole series of numbers for the number of firms in the market. All right. So we first need to find this function or this generalized mapping from the number of firms to welfare in the market. And then in the subsequent step, who can then very easily calculate the welfare for this set of specific numbers of firms in the market. Okay, let's start with this first step. Let's find the function for welfare as a function of the number of firms in the market. How do we approach this kind of problem? Well, let's first think of what exactly is welfare and what do we want it to capture. And as we know, welfare is defined as the sum of consumer surplus and profits, right? Now, luckily, we already calculated profits of the firms as a function of the number of firms in the previous exercises, or previous tasks rather, all right? So we don't even need to think about this part anymore. We can simply rely on our previous results. So what we now need to add to this in order to find the solution is, of course, the consumer surplus as a function of the number of firms. Now, in a case like this, where the demand function is a linear function, we know, and we have discussed this several times in the previous weeks, of course, so I don't want to go too much into the details at this point, but we of course know that we can simply calculate the consumer surplus in a situation like this as the triangle that is defined by the demand function and the equilibrium price, all right? And this formula is really representing the area of this triangle. So we move forward at this point exactly as we did in previous lessons already. The only difference being that this time we are expressing the equilibrium price and the equilibrium quantity as functions of n. All right, so in previous weeks we of course simply had values, equilibrium values that we could plug in at this point. The only difference right now is that we are not plugging in the specific values for price and quantity and equilibrium, but instead we can, again, relying on our previous tasks, we can use the expressions for equilibrium quantity and equilibrium price as a function of n. Just as a quick reminder, going back a few slides, in the context of solving task A, we have found both the quantity in the market as well as the price in the market as functions of the number of firms n. All right. Now we can use these values again in order to find the consumer surplus. And yeah, so we now have found consumer surplus as a function of n. Let's name this CS of n. And we have already expressed on the previous slide the profits, pi of n, all right? Right, so yeah, and with this, by adding up the consumer surplus as a function of n and the profits as a function of n, we of course have an expression for the welfare as a function of n. All right, and this is what is written in this slide, in this line. So welfare as a function of n is equal to 1/2 times 150 times n divided by n plus 2 all squared plus n times 150 divided by n plus 1 squared minus f. All right, n times, of course, because we have n firms, right? So we have to multiply the individual firm's profit with factor n once for each firm in the market. All right, so now that we have found an expression for welfare as a function of n, we can of course simply by plugging in the individual values that we were asking for earlier into this function and calculate welfare for any number of n. And specifically we were interested in a series of numbers for the value of n that was defined in the exercise, so going from 5, 6 all the way up to 15. And now there's one final aspect, one final insight on this slide that I want to highlight, and that is, because it's not specifically asked for in the exercise, but looking at these results, the important part is that we can realize that with the welfare as a number, as a function of the number of firms, actually appears to increase until we reach a number of five firms, and after that decreases again, which is a very interesting behavior, which we will have a closer look into in the next task of the exercise. All right. Now we are asked, as announced, we are asked to interpret the results in the light of the number of companies that will be active in the market if the market is free to enter. Okay, and what we have of course already calculated in task A is that is how many firms will be in the market if there is free entry. So we can of course rely on these results. But first, let's again sketch what let's again make some expectations on what on the results of this exercise. So, as we have pointed out earlier, we can observe that with an increasing number of firms, we see that the overall welfare sees two opposing effects, right? So the first effect is that the consumer surplus is increasing in the number of firms, and you can again verify this and convince yourself of this by having a look at the formula for consumer welfare as a function of the number of firms that we derived earlier. And just have a look at this formula. Once you have plugged in P and Q as functions of the number of firms, you will come to the realization that this is actually the case, that the consumer surplus is increasing in the number of firms. This of course is true because if the number of firms increases, we see an increase in the quantity in the market and a decrease in the price. And then again, just keeping in mind this very simple example in this specific case where we have this linear demand function, of course, with an increase in quantity and a decrease in price comes an increase in this area, in the surface area of the triangle below the demand function. Okay? So, bottom line is, with an increasing number of firms, we see an increase in the consumer surplus. At the same time, what we observe is that with an increase in the number of firms, we see that the profits of each individual firm decrease. Not only the profits of each individual firm decreases, but actually what we see is that the overall profits in the market are decreasing. Okay? So, we have these two opposing effects in this scenario, right? We see an increase in the consumer surplus, but then again, at least for, but then again, we observe for the, within the interval that we were looking at, that the profits actually decrease in the number of firms. So it's not straightforward at this point to answer the question on what the effect is of the number of firms, or the increase of the number of firms on the total welfare, because of these two opposing effects. Okay, so we really can't tell at this point what the the welfare maximizing quantity would be because of these two opposing effects. But what we can see is, if we have a look, if we compare at the number of firms in the equilibrium under free entry, which as a reminder was n equal 14, that this n equals 14 yields a welfare which is lower than the maximum welfare, which we observe for a number of firms of 5, as we have calculated in the previous task. All right, so bottom line is that the welfare maximizing number of firms in this case appears to be smaller than the equilibrium number of firms under free market. Okay, and then just to get a better understanding of what is the driver behind this, well, it really comes down to this overproportional decrease in losses, in profits, decrease in profits, which of course is due to the duplication of fixed costs.